So, how do you do this? Well, I know normally sine and cosine graphs, and I know this is a sine and cosine graph because it's doing this sinusoidal thing, that, as we call it. Those are sinusoidal functions. They repeat, they do this wiggle thing. I'm seeing that this sinusoidal has a midline of 4, y equals 4. And one reason I know that is because above that, it raises up to a maximum of 4 above it, and it goes down 4 below it. So that's one reason I know that 4 is this 4 is the midline, because this amount above is the same as the amount below. So I know this function is a function that's shifted up 4 probably, because it's not bouncing around the x and y x-axis. It's just coming up and hitting the x-axis. I know the amplitude is 4, so I know a equals 4. And then I know the midline is 4, y equals 4. So that's the shift up part. So just to think about this, I haven't said whether I think it's a sine or a cosine graph yet, but I know the first number is going to be 4, and I know the very last number is going to be 4. Now, how can you tell if it's a sine or a cosine? I see this point. You know how sine graphs typically start at the origin, then move up, then come back down, then move like that. And cosine graphs start up at +1 and come down like that. So what I'm seeing here for this graph is this graph starts at the midline. So that's like the sine graph. It's just been shifted up. So I'm going to try to use a sine function for this. You could do a cosine. You just got to worry about the shifting, because normally this starts at the on the y-axis, and this has been shifted over. And then because that's not a nice lattice point, you'd have to kind of guess that that's probably 3.5, which is probably a good guess. But I think it's easier. I know that that is at that point, that 1, 4 point. So there's no guesswork there. So what I'm seeing is, instead of this sine graph starting at the origin or starting on the y-axis, where it's shifting it to the right 1. So what I'm going to do is I'm going to write sine, and I don't know the period yet. I haven't decided that yet, but I do know that it's shifted to the right 1. And I know it's shifted up 4. So now the only thing I have to find is that b number. And to do that, let's see. I'm seeing it starts at 1, goes up, down, back at 11. So that's telling me that's a distance of 10 units. So that's the period. It takes 10 units to repeat. And I know the normal everyday sine and cosine graph have a period of 2 pi. So 2 pi over 10 simplifies to pi over 5. And that's the b number in our equation. And I'm saying that that is the answer to this sinusoidal. And that's what the book says. It's interesting. They also say they could use cosine, where you're saying it's shifted to the right 3.5. So that's what they're saying. I personally think this is the better answer, but both do work. Okay, so I hope that helps.